Let's look at a two-tail example this time. So it says a recent study showed that the mean number of children for women in Europe is 1.5. A Global Watch group claims that German women have a mean fertility rate that is different from the mean for all of Europe. To test its claim, the group surveyed a simple random sample of 128 German women and found that they had a mean fertility rate of 1.4 children. The population standard deviation is assumed to be 0.8. Is there sufficient evidence to support the claim made by the Global Watch group at the 90% level of confidence? Okay, so first we have to figure out our hypotheses. Got to get things set up about what claim we're testing. Okay, so it says we're testing the Global Watch group's claim. So what does it say? It says they claim that German women have a mean fertility rate that is different from the mean for all of Europe. So what was the mean for all of Europe? It was 1.5. Okay, so our alternative hypothesis here is that the mean is different than 1.5. So how can we write that down? It's not saying it's more, not saying it's less, it's just saying it's different. So we use the not equal to symbol. Okay, that's our alternative hypothesis here. So that's why we're getting a two-tailed test. We're using the not equal to symbol here. So for our null hypothesis, we'll use the equal sign. So it'd be mu does equal 1.5. Okay, so those are our hypotheses. Okay, now we want to figure out our test statistic. Okay. So we've looked at the four numbers in our formula. The first number, it's the easiest to pick out in my opinion, is mu. It comes from the hypotheses, so mu is 1.5. Okay. The other number, the next number in our formula we need is x bar. X bar is the mean of our sample data. So if we look, it says in the sample, they found that the women in the sample had a mean fertility rate of 1.4 children. So x bar here is going to be 1.4. Okay. And also tells us the population standard deviation is assumed to be 0.8. So that's sigma is 0.8. And the only other number we need is n. Our sample size, this says a sample of 128 German women, so there's our sample size there. So now we can plug our numbers into our formula. Okay. So to get our z test statistic, we've got 1.4 minus 1.5 divided by 0.8 over the square root of 128. If we punch that in our calculator, I would do 1.4 minus 1.5, hit equal, and then divided by parenthesis 0.8 divided by square root 128, close parenthesis. And here we're at the z, so we're going to round it to two decimal places, so that will round to negative 1.41. Okay. Negative 1.41. Okay, something else we need to figure out is what our significance level is going to be in this case. Again, this one gives us confidence. Sometimes it will just give you significance. Okay? You don't have to always subtract the confidence, but on these two, it just so happens that it's giving us confidence on both of them. So this one says we want 90% confidence. So that to get significance, we got to subtract that from 1. So to get our alpha, our significance level, we'll do 1 minus 0.9, 90%. So we'll get 0.1 is our alpha, our level of significance on this one. Okay, the only other thing we need is we need our p-value. Okay. To get our p-value, this one we have to think a little bit harder on because it's two-tailed, so that's the situation where it's a little bit trickier. Okay, so to get our p-value here, our test statistic is negative 1.41. Okay. But what's going on, since this is two-tailed, we don't only care about the area associated with negative 1.41, we also care about the area that goes with positive 1.41. we want the area in both of these tails. Okay, so in my opinion, the way our tables are set up, the easiest thing to look for is we can find the area to the left of negative 1.41. Okay, so if we find that area, that's this tail. I lost it, hang in there with me. It's 0.0793. Okay, so that means this area is also going to be 0.0793. So either you can think about adding these together or multiplying by 2. So if we do 0.0793 times 2, our p-value on this one is 0.1586. We'll only have to do that multiplying by 2 trick because this is a two-tailed test, so we care about both tails, left tail and right tail. Okay. Almost finished now. Now we are going to compare our alpha 0.01 to our p-value 0.1586. So I like putting my p-value first. P-value is 0.1586. Alpha is 0.1. Okay, so what's our comparison? Well, here our p-value is bigger than alpha. Okay, or in other words, it's not low, right? Our p-value is too big, okay, to do anything with the null hypothesis. So we're not going to reject the null hypothesis. We're going to fail to reject the null hypothesis. Remember, this is a really weak statement. We're not saying the global watch group is wrong. All we're saying is that with this data we have, the evidence is not strong enough for us to reject the null hypothesis.